50 from the homework says we have the two functions y equals 3x minus x squared and y equals x, which I've drawn here. The black one is a parabola and the green one is a linear function y equals x. And this is rotated, the area between them is rotated about the x-axis. We're going to rotate that. So first thing is we have to make sure that we understand how to get that area, and we need to know the bounds of that area. So the first thing is I'm going to solve for the intersection points of those bounds. So to do that, I'm going to make my 3x minus x squared equal to x, and then solve this equation. So I end up with x squared minus 3x, or sorry, minus, this is going to be 4x. Minus 2x equals 0, and then my intersection points are going to be at x equals 0 and x equals 2. So that's going to be my intersection point. So those are the red dots there, and they represent the bounds of my integration. Now the other thing that's going to happen is when I rotate this, I'm going to end up with washers. Okay, so I have washers that I'm going to end up with, and for washers I need to make sure that I understand what the outside radius is and the inside radius. So I'm going to have an outside radius, and that's going to be the black function. So if I imagine rotating this, so I've made a big R here in black, you can see that little black line is going to be the big R, and if I rotate around the x-axis, that little green line represents the inside radius. So I'm going to have my inside and outside radius that gives me that area. Okay, so there's my area, and the outside radius is going to be my big R, which I've labeled. Okay, so that's my big R, and then the inside radius is going to be this little r in here. And to find the area of that washer, is going to be big R squared, pi times big R squared, minus pi times little r squared. Okay, and then I can just factor out the pi, and I end up with r squared minus r squared. So setting up my integral then, my integral looks like this. The volume of the rotation is going to be, I'm going to factor the pi out of here. I'm going to have my bounds from 0 to 2, and I'm going to use dx's, so I'm going to use dx slices. My washer slices are going to have a radius, the outside radius, which is 3x minus x squared minus the inside radius circle, which ends up being x squared, and then I'm going to multiply that by a thickness of dx, and that represents then my integral for the volume of that solid that I generate by rotation and with washers. So if I take a look at my answers, the answer is C. Okay, I can see my r squared here minus my little r squared here.